good morning, good afternoon, good evening, depending on when you're watching this video here. So hopefully this is the third video you're watching for our first online program here. So the first video, of course, we had the statistical lies, and the second one we talked about establishing cause and effect relationships. And so now we're moving into chapter 2. So this this video should get through most of chapter 2. Here we will actually be using StatCrunch while we're watching this video. So if you want to log into StatCrunch right now, I would advise it, and maybe have it open on your phone or some other device. StatCrunch, the login is the same login you use for the MyStatLab, okay, and the subscription comes with the access. But yeah, so a lot of the things we're going to be doing, we're going to be calculating using StatCrunch. It's a very powerful tool that allows us to work with interesting and real data sets, and so that's what we're going to do. Okay, so so chapter 2 is about picturing variation with graphs. So in chapter 1, we're really answering questions about the graph. You know, who collected the data, how was it collected, what type of variables are we dealing with here, and what was the size of the sample, and we're thinking about, well, what conclusions can we make with this study. So, you know, does this data come from an anecdote, does it come from an observational study, or does it come from a controlled experiment? And so now, you know, more or less, once we've answered those questions, we can move forward and start trying to summarize and visualize our data, so we can learn more about it. So in here, this is just kind of like a pie chart here, and it just says, what do 7 billion people do? So here you have 1.9 billion are too young to work, 1.7 billion can work in services. So this kind of represents kind of like a pie chart that is used for categorical variables only, okay, not used for numeric. So we're going to learn that, you know, the type of variable is kind of determine the type of graphs that we could make. So if we look here, I mean, really what these graphs here, so we can focus our attention on this histogram here. It's just kind of a visual of the point distribution for a particular exam. So if we look here at this rectangle, we see a majority of students here. See, a majority of students, maybe about 55 students scored between 50 and 60 points. And then as we get further away into, you know, the A range, there's less and less students scoring that high. And as we get further away, you know, in this, I don't know if that's even F, that's F minus range, less and less students are scoring there. Okay, but what this kind of helps us visualize is the distribution of a sample. Okay, so the distribution of sample of data is one of the central organizational concepts of data analysis. And in theory, it's kind of difficult to understand, but it's just a matter of, if you remember in class, when I was having you pick a number between 1 and 9, right? I was writing the numbers down. How many people select 1, how many people selected 2, and a lot of people selected 7. You know, I would make a histogram down there. We're kind of getting a visual, like the distribution of responses. Like, okay, I know 1 through 9 are going to occur, but is 7 more likely to appear than any numbers, or something like that? So it says here, the distribution organizes data by including all the values observed in the sample, as well as how many times each value was observed, the frequency. So that's a lot of it. So we're just creating these categories here, and then the frequency, we're just counting, okay, well, how many of my results are here? How many of my results are here? Okay, so that's where the distribution of the sample. Okay, so usually we're interested in what's the center, what does the spread look like, so on and so forth. Okay. So a first kind of plot that we use for this numeric data, or it could be other types as well, is something called a dot plot. So it says for a dot plot, we simply put a dot above a number line where each value occurs, and then we look for any patterns, right? So in this dot plot above here, we have number of siblings. So number of siblings are 0, and then we have 1, 2, 3, 4 dots. So what that means is that in my study, there are 4 participants who are only child of their family, right? This dot here, which is the most frequent, we have 1, 2, 3, 4, 5, 6, 7, 8. So that means of my subjects, 8 have just one sibling, right? So we see right away we're looking for patterns, right? We see that 1 is the most common, and 4 is the least common, right? There's only one subject where they had 4 siblings, right? And so same thing here. We can ask just another example here. We have number of shoes students have. Okay, so here as far as having 8 pairs of shoes, there's 1 student. The most common is 10. Okay, 10. There's 1, 2, 3, 4 students that have 10 pairs of shoes. Out here we have 1 student that has 16 pairs of shoes. But more or less, what we go is from just looking at the data in the frame to this nice visual, so we can kind of determine, okay, what's the most frequent maybe observation, what's the least current, things like that, okay, with the dot plot. Other things we can work on are histograms. So histograms are similar to that of dot plots, but they can provide a smoother graphic by grouping observations into intervals or bins. So for each bin, either the frequency or the relative frequency is recorded. So I mean, here the bin width is 1. Okay, so because we're just dealing, 0, 1, 2, 3, 4, 5, 6 number of MP3 players. But one thing to note about these graphs in red and blue and red is that they're both histograms and they look exactly the same. Okay, the only thing that's different is the labels on the y-axis. So here frequency, so when you see frequency is just the counts, right? So it's just saying here, for here roughly, I don't know, 32 have 1 MP3 player, right? And here it's saying roughly 2 have 0 MP3 players, so on and so forth. Now here we're just doing relative frequency. Okay, so remember, relative frequency is just the frequency, the count, over the total number of observations that we had, or the total sample size, right? So here, how they got this here, this is roughly, it's saying it's roughly about 34%. So now it's saying roughly 34% had 1 MP3 player. So how they did that was they just counted, they did the frequency and divided by the total sample size to get this percentage here, right? So we did some calculations similar to that with the contingency tables. We're doing the count divided by, and we can go to decimal and go to percent. So that's how they do that here. Okay, but one thing to note is the bins here. Okay, so just note, if you've been in the stats course before, we're not going to be constructing these things by hand. Okay, StatCrunch will be doing most of the lifting for us there, but what's important is that we can interpret what these graphs show. And then we get into histograms and bin width. So this is an example here. So here, I don't know if you remember, I was referring to home prices in San Luis Obispo County. And what I did is I just created a histogram for the square footage of these homes. Okay, so this histogram and this histogram, they're recorded using the exact same data, but what I changed was the length of the bins. So the bins in this example, this is what DataCrunch did by default for me. It did interval lengths of bin lengths of 1,000, because we go from 0 to 1,000, 1,000 to 2,000, 2,000 to 3,000, and so forth. So I looked at it and I said, you know what? Let me shorten the bin width a little bit in StatCrunch, which is very easy to do, and actually I'll be showing you how to do that today. So here I just shortened it up to 500, because you go 0 to 500, 500 to 1,000. So you see, I mean, we roughly get the same shape. Okay, nothing too weird happened here. Okay, but we can kind of see that a majority of the homes that were for sale in this data set, a majority of the square footage ranged between 1,000 and 2,000 square feet. And of course, we had a couple homes out here that were like 7,000 square feet. Okay, all right. So the other thing we can work on is a stem plot. Okay, so a stem plot works very well for smaller data sets, and it works very similar to that of a histogram, but we can more or less see what's stacked on top of each other. Well, we can see what's in each bin, I guess, right? So in order to create a stem plot, we need to determine what is the stem and what is the leaf. So the leaf is the last digit in the observation that we want to round to, and the stem contains all of the digits. Contains all the digits that precede the leaf. Okay, so in here, this data, we're just recording age. Okay, just age, and then down here there's a key, right? So these are the stems, and then these are the leaves here. So here, if it has the stem is 6, the leaf is 3, then the 6 is the tens place of the number, and this 3 is the ones place of the number. So when we have something coded as 6 here and 3 there, it means we had one subject that was 63 years old. Now, of course, if we have 0 and 1, it means we have 1 years old. Okay, these 4s here, there's 4 4s here, it means we have 4 participants that were 4 years old, right? This 0 here means we had a participant that was 10 years old. So we have 1, 2, 3, we had 3 that were 10 years old, right? And of course here, if you look at these 2s here, well, that's saying the stem is 3, the leaf is 2. It means we had 3 participants that were 32 years old. Okay, so in here, you know, we can still see it's kind of like a histogram kind of rotated 90 degrees. Okay, where we can see which age range was the most frequent. So the age range that was most frequent was between 1 and 9 years old, right? The age range that was least frequent was the age ranges that were in the 60s, right? Those are the least frequent. So, you know, we can still kind of see these in terms of like a histogram here. Okay, so let's do an example here. So now what I'm going to do is go to StatCrunch, okay, and show you how we can create these plots using the software. Okay, so like I said, I don't want you guys to, doing these by hand is not really part of the course, but being able to use technology to recover them is important here. So let me go ahead and go here to, let me open up my StatCrunch. Okay, so this is my StatCrunch here. Make sure to log in. Your login and password are the same that you use for MyStatLab. Okay, what I want you to do is go into, I think I had MLB there, so we can just go to data. Okay, go to data, and then you could just type in MLB here. Okay, no, not that. Okay, MLB, and then we'll search here. Okay, so here I want to examine the 2014 Major League Baseball top 100 batters. Okay, so we always read these here, just saying this data came from ESPN.com. And it has top 100 batters by wins above replacement. Okay, by the statistic here. Okay, but here they list what each variable here. AB is at bats, R is runs, H is hits, doubles, triples, all that good stuff there. So we click here. StatCrunch is going to open up the data for us, and here it is here. Okay, so here you have a long list. Okay, so we have about 100 rows of observation, and we want to maybe look at home runs. Always interesting, right? So let's say I want to create a graph for home runs. So we could start off with the dot plot, I suppose, and so I do a graph. Let's do dot plot. So here, if I want to construct a graph, which of these buttons do you think I'm going to use? Well, probably graph. Okay, so let's click on graph here, and let's go to dot plot. And then I want to select the column. So I'm looking at home runs. So let's do home runs. Okay, and you notice here they're only going to give you the numeric variables. Okay, but here I do this here. Here's some other options that we'll visit later, but here we compute. Boom, there it is. Okay, and there's my dot plot here. Okay, so here's my dot plot here, and we can see here, the home runs for these hitters, the totals, they range from 40 all the way to this amount here. Now, if you examine my cursor, I have this kind of crosshairs, this little plus sign there. And so the cool thing about StatCrunch is, who was this that hit the most home runs? Well, if you just click and drag, okay, and let's see who hit like the least amount of home runs. Click and drag, there you go. And you see down here it's saying, hey, we have 3 rows for you. Okay, so now what we can do here. Okay, now what we can do here. Okay, now what we could do here is we could scroll down here and find out who that was. Right, so here we have Nelson Cruz, who hit 40 home runs. Okay, so they had the most home runs out of these hitters. And then here we had Jared Dyson, who hit 1 home run. And then we have who else do we have here? Let's see. And then we have we have Adam Eaton, okay, who only hit 1 home run. So very nifty and powerful tool in using StatCrunch. For one, it calculated the dot plot relatively quickly, and also there's built-in functions that easily allow us to navigate the data and find these kind of observations. Okay, let's create another graph. Let's do a histogram. Okay, so we could do a histogram for home runs. Okay, so I go in here, I do home run, compute, and there it is. Okay, so we can kind of see, so this is kind of like what we're talking about, the distribution of the sample. Okay, just like how we did with the other one. Right, we can see a lot of home runs are within this range, not too many out here in 40, a little bit here in 0, but you see we have them here. But even too, if you wanted to find out which observations these were, like who hit this amount between 30 and 35. So if you hover the cursor over the bar, it'll give you information. So the frequency is saying there's 4 home run totals that were between 30 and 35. And if you click on it, right, it's automatically going to highlight and tell you who those players were. So very, very nifty as far as sifting through a data set, because these are very large data sets. By eye, if we're going through these, we're gonna give up just because we have to sift through the data. And so so having tools like this makes life a lot easier, and we could deal with more meaningful data sets. Okay, so one thing to note is that what if we want to compare groups and things like that. So I can go options and show you something that's kind of cool. So maybe I want to look at like home runs, but with respect to different groups, right? So remember in the death penalty case data, right, we separated the data by race of the victim, right? So we kind of grouped them, right? And so here, if you look here, we have this group by option here. So I can group by, let's say, league, okay? Because in baseball, there's a National and the American League. So what this will do is it'll create for me 2 different graphs, but one where the data is only from the National League and one where it's just for the American. Okay, and so you see here I get the one graph here, okay, but I get league is equal to American, right? So we get the graph here. And then actually if you go here, both, there's actually 2 players who I guess during the season were traded, but for half the season they played for National League, the other they played for the American League. So that's why it looks funny, because it's only for 2. Because see, this is frequency 1 and this is frequency 1, and of course if we could click on this, we could determine who that is. Okay, all right, but if you go here to National League, okay, here's our other graph here, right? So we get our separate graphs. So very easy, very nifty, and very quick to do. Okay, very easy to do here. Okay, using StatCrunch here. And just keep note of this interval here. Remember your interval notation. On the 15 here, there's a closed bracket. So meaning if the home run was 15, it's included in this interval. And if we look at 20, we have that open bracket. So what that means, if there was a home run total of 20, it was not included here, and it was given into this one here. Because see, in this next bin that's adjacent to it, we see here 20 now has a closed bracket, so it means that it would be grouped there. Okay, so all right, so I guess one other type of chart that we could do is the stem and leaf. Okay, so I could do stem, and I can do home run, and I could just do it like that, and that's what that will look like there. Okay, so stem and leaf is pretty nifty, and it gives us it looks very similar to the histogram that we created, just kind of shifted 90 degrees, I guess. But also it kind of tells you how things were stacked. But if you notice here, the stems, we have two stems of 0. And so what it did there is that, well, there's a lot of home run totals that are between 1 and 10. So what it's doing here, this stem, it's only including 0 to 4, while this stem is including 5 to 9. Okay, so same thing here. For this stem 1, it was kind of broken in half, right? Because there's just too many leaves for this stem, so they broke it in half so it could support all these leaves. So this one here goes from 10 home runs to 14 home runs, whereas this stem here is going from 15 all the way to 19 home runs. Okay, but pretty nifty here because you can see, okay, all these totals are 17. This is how many times 17 home runs appeared, 40 home runs appeared once, 35 home runs appeared twice, 7 home runs appeared a whole bunch of times, okay, so on and so forth. Okay, but very straightforward in doing and StatCrunch as far as dealing with the data here. Okay, all right, let me click out of here really quick. Okay, so once again, so this StatCrunch, you don't have to have your computer out. You could be using your cell phone, and you can easily navigate through this material here. Okay, so now what we want to get into is, okay, now we're able to create these awesome plots, but how do we interpret them? What's the jargon that is used to interpret these distributions, right? These graphs. And so here we're summarizing important features of a numeric distribution here. Right? So what are some important things to include? What are common phrases that are used to explain these? Okay, so when we're talking about how we explain here, the main three things we're looking at is the shape, the center, and the spread. Okay, so the shape here is, are there any interesting or unusual features about the distributions? So some things we may want to say is it's symmetric and bell-shaped. So symmetry here, so this graph here would be considered somewhat symmetric and bell-shaped. I mean, if I were to throw a blanket over this, we would kind of get that bell-shaped. But by symmetric, they mean if I were just to draw a line right here, right in the center, right, this graph would more or less be, these halves would be mirror images of each other. So that's what we mean by symmetric. And it just so happens, I mean, we don't know why this happens, but a lot of times in the phenomenon that we observe this a lot. Like there's an average, and there's just a lot of outcomes that are very close to the average. And then as you get further away from the average, it's less and less likely in both directions. Okay, so that's one of the most common ones that we will see. And of course, things can be right skewed or left skewed. So if they're not symmetric, they could possibly be right skewed or left skewed. So this graph on down here, it's left skewed because it's kind of stretched out thin to the left, right? And so, I mean, if this were like a distribution of test scores, this is what we would want, because we want a lot of scores here in the 80s and 90s and not so many out here in the failing scores, right? Here, this is an example kind of something that's skewed to the right, right? It's kind of stretched out thin to the right. So this type of distribution for test scores, we definitely don't want, because we've got a lot of scores that are failing and not very many that are in the A range. Okay, and of course, we're also looking for things that have different modality there. Okay, and also we're looking for center. Right? What's the center here? Maybe this is like the center value, right? Maybe here the center is here. Maybe the center is about right here for this distribution. And also we're looking for spread, right? What is the range of scores for this example? So here our variation, it's pretty much from 0 to 100, 0 to 100, 0 to 100 more or less. Okay. So in terms of modality, right, when we say something's unimodal, bimodal, multimodal, it's kind of like if you have these histograms, and it could be also a dot plot or a stem and leaf chart. We can apply it to any one of these. If we throw a blanket over it, how many humps are we going to see, right? So if I kind of threw a blanket here, right, we would have one kind of hump, one kind of frequent outcome, or a set of frequent outcomes. Okay, bimodal here, if I throw a blanket here, I have a hump here and a hump here. Okay, so it just means that there's two points of that have a higher frequency. Okay, where there's a spike in frequency. And of course, in multimodal, we just have, more than one hops. And in practice, this could mean a bunch of different things. It could mean, maybe there are groups, inherent groups within your data, and those groups, they kind of follow their own kind of unimodal distribution, right? And where their modes are not lined up exactly with each other. And so when we graph them together, we kind of get this bimodal kind of looking graph, right? So that's what these things can mean here. Okay, they're different values with relatively large frequencies. And then when we're talking about spread here, spread. So if you look here, these are test scores for verbal, math, and spatial, right, for students. So if you look here, they all relatively have the same center, right around 90, 90, 90. Okay, and they all seem to be unimodal, right? They all seem to be unimodal, and they all seem to be like bell-shaped symmetric. But what's different here is the variation, right? The variation of scores here is from 80 to 120, say, and then from here it goes from 60 to 140, and then here it's going from 30 to 170. Okay, so what this could indicate is that, especially out here, is that here the abilities of the students taking the exam, they're more or less comparable, right? They all have the same ability to tackle this verbal. But then once you go to math, the abilities in math, they have more variation, right? We have some that aren't so good, some of that are pretty good, but there's more variation in the skill set of the students in terms of math. Then we get to spatial, we even gets more variation. So this is kind of indicating that kind of more or less the skill level in our students is there's a lot of variability there when you get to the spatial IQ part of the test. Okay. So, and other things we need to always look out for are outliers. Okay, so meaning we can have this histogram here and a bunch of white space here, right? No observations here, and then an outlier. Okay, so outliers are just points that are not consistent with the data, and they're not bad. Sometimes that's just inherent in the phenomenon that we observe. A lot of times we see it like in home prices. For example, these are like the distribution of all the home prices within a certain area, like in Montecito, but then you have like Oprah Winfrey's house, right, up in Montecito, right? So her house, the cost of her house, right, her home price is going to be way more than everything else in Montecito. And so it's typically like for home prices, you see median home price, not average, and it's because of things like this, because we always have one home price that's so ridiculously expensive in comparison to all the others. Okay, but we always need to pay attention to these, right? Like how did that outlier get there? Is it just because someone's house is worth that much, or is it because we made a mistake in data entry? Maybe we just added an extra zero when we shouldn't have. Okay. All right. So the next thing we're going to do is get ready to look at some examples in StatCrunch. Okay, but before I do that, I'm going to take a little break.